Hi everyone, welcome to lesson number 2. We're going to be looking at operations with functions, part 1. And to begin with, we're going to be investigating the sum and differences of two different functions. So here on this table of values, I'm given two functions. I'm given f of x and I'm given g of x. And each function has a y value that will pair up with a x value. And what we're going to be doing is finding the sum. So we'll be adding our two functions, f and g of x, together. And we're also going to be subtracting them from one another. So the table of values shows f and g here. So -7, -5, -3. These are the values that you'll find along the y-axis. Again, these are also the values that you'll find along the y-axis. What we want to do is we want to start by plotting the points of x and f of x on the grid. So we want to start by plotting these points. So at -4, I'm going to be plotting at -7 for f of x. So this is function f of x. And then afterwards, I'm going to highlight both of the functions so you'll know which one goes with which function. So from -4, then I go up to -3 and -5. -2 and -3, -1 and -1. Now so far I have my function f of x, and I'm gonna label this in a moment as function f of x. But before I label it, I'm just going to draw my line. So function f of x is going to be the orange line. Now I'm going to start graphing g of x. So my first point is at -4, -7, same as the first point on f of x. But then I go to -3 and -6. And then -2 and -5. And then -1 and -4. Here's my function of g of x, and I'm going to be highlighting this one in pink. So now that I have my two functions graphed, I can go ahead and start plotting the sum of function f and function g. And so first of all, when I'm plotting the sum of function f and function g, so what I'm going to be doing is just adding my y values together. So -7 and -7, I'm going to get -14. -5 and -6, I'm going to get -11. -3 and -5, I'll get -8. And then we'll continue filling the table in by adding my two y values together. Oh. -5, -2, 1, 4, 7. Now, I'm going to be plotting f plus g of x on the graph. So just like I did before, the x value corresponds to a y value. So this x value corresponds to this new value of -14. So -4 and -14. Now I'm going to go ahead and draw my line. And I'll shade this one in green. And this is f plus g of x. Now I need to determine what f minus g of x. So all I'm doing is subtracting f and g from each other. So that will be 0, 1, 2, 3, 4, 5, 6, 7, 8. This line will be fairly easy to plot. So negative 4 and 0. Four. And I won't shade this one. I'll just call this one f minus g of x. So the functions f and g on the previous page are f of x is equal to x plus 1 and g of x are equal to x minus 3. Write expressions for the functions f plus g of x and f minus g of x. Well, f plus g of x is equal to, so 2x plus 1 plus x minus 3. And so if I gather my like terms, I have 2x and x is going to be 3x, 1, and negative 3 is going to be negative 2. So f plus g of x is equal to 3x minus 2. Whereas f minus g of x is equal to 2x plus 1 minus x minus 3. So if I simplify this, I have 2x minus x is going to be x, and I have positive 1, and I distribute this negative into, or I'm subtracting a negative 3, so I'm actually going to be adding 3, so it's going to be 1 plus 3 is 4. So f minus g of x is equal to x plus 4. We want to state the domain and range of both of our functions. Well, so for both the domains, x is an element of real numbers, since every value of x we'll find on our graph because they're continuous lines, and there's no restrictions. And same with the ranges. Both ranges are also, my y value is going to be elements of real numbers. Now determine the value of f plus g of 10 and y is equal to f minus g of negative 10. So if I have f plus g of 10, then all I need to do is plug into my original equation. So that was 3x minus 2. 3 times 10 minus 2, which is equal to 3 times 10 is 30 minus 2 is 28. So f plus g of 10 is equal to 28. And f minus g of negative 10, we'll do the same thing, but in this case we're going to be adding a negative number. And this is f minus g, sorry. So mistake. So negative 10, we're plugging it into this equation, plus 4 is equal to negative 6. So in this example, the sum and difference of two functions of degree 1 are also functions of degree 1. Can you find two functions of degree 1 whose sum or difference is not a function of degree 1? Well, if I have f of x 3x plus 6, and if I have g of x equal to, let's say, 3x plus 4, so can you find two functions of degree 1 whose sum or difference is not a function of degree 1? So in this case, if I were to find the, let's say, f minus g of x of something like this, where the slope is exactly the same, this is going to be 3x minus 3x, which would be 0, and 6 minus 4, which would just be equal to 2. So if the slope is the same, that would give me a constant function, right? And so this constant function would have a degree of 0 because there's no x value. So in part 2, we're going to be looking at the graphs of two quadratic functions. So I have y is equal to f of x right here. And sometimes it's helpful if you color them, even though it is labeled for you. So we have that, the pink function, the black function. We want to use the graphs to sketch the graphs of y equals f plus g of x and y equals f minus g of x. So one thing that's helpful is if you just list the y values for every x, or sorry, the y values for every x value on a little table. And so what we could do is build a little table of values, something like this, and then I would have my x values here, and then I would start building my list for f plus g and f minus g. Now, if we look at the lower end of my graph, the one where they have a common point that we can see is at -3. So there is a point here at -5 and over here at -6, but we don't have those values for this f of x. So we do have values at -3. So if I'm looking at f plus g, then at x equals -3, then I have something like, let's see, this is at 2, 4, 6, 8, 10. So this goes up by 2. So 24 plus I have 1 here. So 24 and 1, that y3 is going to be a 25. And as we increase, so that will be -2. So now at -2, I'm at 4 and I'm at 12. So that next value will be at 16. Next, I'll be at -1. So at -1, let's see here, I'm at 4 and 5, and so I got 9, 0. So at 0, I'm at 0 and 4, so the new point will be at 4. At 1, I'm at 0 and 1, so we'll have 1 and 1. All right, so I finished the table of values for my f minus g of x, and I also plotted my first point, so f plus g of x. And I'm gonna highlight that function in green here. So here's my lowest point. So it goes down like this, and then it goes back up, and it looks something like that. Now I'm only gonna be graphing one of them, just in the interest of time. And so here's my graph, f plus g of x right here. And now we're gonna move on to part B. The functions f and g above are written as f of x equals 2x squared minus 2x and g of x equal to -x squared minus 2x plus 4. We want to write the expressions for the functions. So if I have f plus g of x, this is going to be equal to my function f, which is here, 2x squared minus 2x plus -x squared minus 2x plus 4. This is going to equal, if I combine my like terms, 2x squared, -x squared is going to be x squared. -2x and -2x is going to be -4x. And then I have positive 4x. So this is the function that we graphed. Now the function that we didn't graph is the difference between f and g of x. So we're going to be subtracting -x squared minus 2x plus 4. Now when we combine these like terms, sometimes it's easier, we'll rewrite it down here, but we'll write 2x squared minus 2x and plus x squared plus 2x minus 4. Combining like terms, I'm going to end up with 3x squared, and I have no middle term, and then I have -4 for my final function. So here are my two functions that were combined, the sum and the difference.